All right, so this next video is about the geometric distribution, and I'm not going to go into the geometric distribution as I did with the binomial distribution. And for one, I think the geometric distribution is actually easier. So a geometric distribution or experiment is basically, instead of counting the number of successes, what you're doing is you're counting the number of trials until the first success. So a trial is repeated until a success occurs, and this is really the main thing you have to remember. Geometric, you keep doing it until you get a success, and then you stop. In binomial, I tell you how many trials there are, or you know how many trials there are, and you count the number of successes. Geometric, there could be one trial. If you get a success right away, you're done. Or there could be 100, 1,000, million, trillions of trials until you get that first success. That's all we care about. And repeated trials are independent of each other. This is the same as binomial, and the probability of p is constant for each trial. So these two are same as binomial. These are the same as binomial. But the first one is a trial is repeated till a success occurs. That's the main thing that we have to remember. So let's do a couple examples about Shaquille O'Neal here. So for Shaquille O'Neal, it says a basketball player, Shaquille O'Neal, makes a free throw shot about 0.526% of the time, or 52.6% of the time, which is 0.526. So that's our probability of success for Shaq. And we want to find the probability that the first shot O'Neal makes is the second shot attempted. So Q then, because you still need Q, is 0.474. Now, let's go to the question. The probability that the first shot O'Neal makes is the second shot attempted. So basically, he shoots, and let's say he misses, and then he shoots, and then let's say he makes it. So we'll say that means success. So he misses, and then he has a success. So, well, the probability of x is the probability of him missing, which is 0.474, because that's the probability of a failure, and the probability of him getting a success then. So we just multiply them, basically. So you basically just multiply how many misses you have until that first success. And when you do this, you get 0.2493. And that's exactly what this formula is up here. We take the probability of success, because there's only one success, and there's always only one success. The probability of success is just 1, and the probability of failure is q, and there's x minus 1. Because if you're shooting the ball, let's change it to 5 times. Let's say Shaq shoots it 5 times, and he makes it on the 5th shot. Well, how many failures did he have before that then? 4. That's where the minus 1 comes in, because you're subtracting that one success on the exponent for q. But if you just think about it, it's not that bad. So let's do another example. From experience, you know that the probability you will make a sale on any given telephone call is 0.23. Find the probability that your first sale on any given day will occur on your 4th or 5th sales call. So the key for this one is 4th or 5th, so you're going to have to do something twice, because you have to add the 4th and 5th together. But our probability of success is 0.23. Our probability of failure is 0.77. So we want to find the probability that x is equal to 4 or 5. So we have to add those together. So let's just find the probability x is equal to 4. Well, the probability x is equal to 4. So my first sale occurs on the 4th call, means that we got our first sale, so we only have one sale. And then we have, how many failures did we have before our 4th sale? Well, 3. So we had 3 missed calls, or no sales, and then we had 0.23 for the one success. So this is the probability of the 4th success, plus probably the 5th. Our first sale is successful on the 5th. That's our success. And then if we had our first sale successful on the 5th, that means we had 4 failures before that. And we can put this in our calculator exactly as we see it. And if we do that, we get 0.18959. This is exactly what the formula is. So let's do the let's do the next one here. Find the probability that your first sale will occur before your fourth sales call. So X is before the fourth sales call. Well, this could be the first sales call. So think about this. This could be the first sales call, the second sales call, the third sales call, and that's it. So I'm just going to write all these out. I could keep going on and on. So it could be the first, second, or third. So we have to do the formula 3 times this time. So if our first success is on the first sales call, that's 0.23. We always start with 0.23. And we had no failures. So that's to the 0 power, which is 1. 0.77 to the 0 power is 1. Okay, and then 0.23, if our first success is on the second sales call, it's 0.77 to the first, because we had 1 failure before the second call, which was a success. And then we do the third, which is 0.77 to the second, right? Because if we had 2 failures and then our third was our success, and that's it. And so we can add all those together, and that's 0.5435. And then our last one, find the probability that your first sale will occur after the fourth sales call. Now, this is an interesting question because if it's after the fourth sales call, well, it keeps going on and on. But these are probability. Each of these has a probability, right? It's a probability distribution. But all of these probabilities, if you find all of them, if you add them all together, remember, the sum, that should be a sigma, but it's a very messy sigma. The sum of all the probabilities equals 1. So you're adding up an infinite number of things, and you still get 1, which is pretty interesting. At least I think it is. So we want to find the probability. We want to find the probability that our first sale will occur after our fourth sales call. Okay. Well, here's the thing. If your first sale occurs after your fourth sales call, what happened before that? Well, you had 3 failures, didn't you? If your first sale occurs after your fourth sales call, you had 4 failures, right? Because if your first sale could be on the, so it's actually past this, it's 5 and on, because it's after the fourth. So your first sale could be on the 5th, the 6th, the 7th, the 8th, and so on. So that means you don't even need the formula for this. If you had 4 failures before your first sale. So all it is 0.77 to the fourth. That's it. 0.77 to the fourth, which is no, it's not letting me do the caret. Okay. Oh, that's because I don't have a scientific. So let me do the scientific. Okay, there we go. Now it let me. Nope. 0.3515. And that's a geometric distribution, so not that bad, right? All you're doing is if your first success occurs, okay, you figure out where that is, you use that probability 1 time, and then you count how many successes are before it, and you multiply by that many, or how many failures are before it, and you multiply by that many failures, and you get your answer. And if you need to or if you need to add multiple scenarios together, like we did in this one, you do that. So on the next part of these notes, I just want you to read each problem, and I want you to tell me if it's geometric, if it's a binomial question, or if it's a neither. It could be neither geometric nor binomial. So try to do this part on your own and pause the video, and then we'll go over it. So for the first one, it says, what is the probability he will hit his first home run? So that is the first success, so that is a geometric problem. Right, because he's going to keep hitting he's going to keep hitting until he gets his first home run. This one is a neither, and this one's actually called a poisson, which is fish in French, is what I'm told. But yeah, you don't have to know that. It's just what it is. But notice how it's not talking about the first success. Some people say binomial on this one because you're trying to find out how many people get killed by sharks. But the thing is there's no number of trials. This is actually the average number of people that get killed. It's not telling you a probability of success. It's not telling you how many times you're trying to see if someone gets killed. You know, which would be kind of morbid, like you're just throwing people in the water until they get eaten by a shark, which is kind of weird. If that was binomial, that's what it would have to be. So it's not. The last one, though, is binomial because they give you a probability of success, right? 1 in 4 adults are dieting, so that's your success. You have 8 adults, so that is your number of trials, and you're counting how many people are on a diet. So out of a set number of trials, so that is binomial. And that's basically 4.3. So make sure you know when you are in a binomial situation or a geometric situation, because I won't tell you what situation is what. You're going to need to identify that for yourself.